Fourier series of odd and even function. So let's consider first the first case. Say we have f is odd and we are working with the function f of period to L. So L is half of the period and this function is piecewise continuous. The general formula of Fourier series is ft, and if necessary we can change and redefine f so that at the points of discontinuities this is the average of the left hand and right hand limit. So we have Fourier series of ft equal to a naught over 2 summation an cosine n pi divided by lt plus bn sine n pi divided by lt, and from 1 to infinity. And a0 is 1 over L minus L to L ft dt. An 1 over L minus L to L ft cosine n pi over L t dt. And we can use one formula for both a0 and an. So for example, for the second formula we can start n from 0. So this one will be cosine of 0, which is 1. So that implies this formula. And we have bn 1 over L minus L to L ft sine n pi over Lt dt. And because our function is a period to L, so the function we defined from the intervals. Say here I compute the interval from minus L to L. We can choose any interval of length 2L. For example, you can compute that 1 over L from 0 to 2L ft dt. This one will give the same result as this one. We can choose any interval of length 2L to compute the interval. Similar for this one and this one. You can choose from 0 to L. Now our function f is odd. So I think we should use this formula to compute the integral. F is odd. Recall that you take the integrals, say from minus a to a ft dt, you get 0. Integral of an odd function over a symmetric interval. So for example, you can do the integral area under this curve. This area equal to minus this area. That's why we have 0. So a0 equal to 1 over L times 0, which is 0. an 1 over L of this. ft is an odd function. Cosine is an even function. Odd function times even function. We get an odd function. So this function is odd. This function is odd. Integral of an odd function over a symmetric interval. This one is 0 for all n greater than equal to 1. And we have Bn. This is odd. This is also odd. Odd function times odd function. You have an even function. This one is even. Integral of an even function. We call that integral from minus a to a, say function g t dt equal to 2 times 0 to a gt dt. So this one is 2 times 2 divided by L times 0 to L ft sine n pi over L t dt. So now we computed all the coefficients. The Fourier series f here, ft equal to this one 0, this one 0. So summation now contains only the sine terms. And from 1 to infinity, sine Bn sine n pi over L t, where Bn equal to 2 divided by L 0 to L ft sine n pi over Lt dt. So this is our Fourier series of an odd function. And you do similarly for the case f is even. This general formula here. And note here, f is odd. Second case, f is even. F is even. This one is 2 times 2 over L times 0 to L ft dt. Integral of an even function over a symmetric interval. So we take half of the interval and then we multiply by 2. ft is even, cosine is even, so this one is even. So an equal to 2 over L 0 to L ft cosine n pi over L t dt. This is an. Bn. F is even, sine is odd, this function is odd. Interval over a symmetric interval, 0 for all n. So now we have the Fourier series. These terms 0. So ft equal to this. Where a0 is 2 over L times 0 to L an 2 over L. This. Again, we can use the same formula for a0 and an, because when n equals 0, this term cosine of 0, which is 1. So this is a Fourier series of uneven function. Now for a function f is given on the interval 0 to L. We can extend f to an even or odd function. Extend f to f odd from minus L to L in the following way. F odd of t equal to f of t for t between 0 and L, and equal to minus f minus t for t between minus L to 0. By definition, this one will be an odd function. F odd is odd. And now we extend that in such a way that this is a period function. Then we want f odd to L period to L, and is defined on one full period as this formula. Now the Fourier series of f odd as we talked before, the Fourier series of an odd function given by this f odd, and we say that this is a Fourier sine series of f. So this case, f odd on the interval 0 to L is the same as 0 to L is the same as ft by our definition, and pi t dt. And we call this one the Fourier sine series of f. F is given on zero to L initially, and we extend f to an odd function, a period to L. So we extend it from minus L to L, and that function is one full period, and we extend it to other interval. Fourier sine series of f is this one. Ft equal to 4bn is given by this integral. So here is a definition of Fourier sine series. And similarly, we can define the Fourier cosine series by extending f to an even function. Now, instead of extending f to f odd, we will extend it to f even. Fourier cosine series. So we are given f interval from 0 to L. F is equal, so 0 to L is the domain of F initially. Is given on the domain 0 to L. Now we extend F to F even. So that's one, we have the domain minus L to L for one full period, and then for the other period, for the other interval, we will just copy what happens here. So a period to L. So F even is divided as follows: F even t equal to Ft for t between 0 to L, and F minus t for t between minus L to 0. So this is the definition for F even on the interval minus L to L, and for other interval, for example from L to 3L, it will just repeat this pattern. So we know that the Fourier series of F even will be, the series contains only the cosine terms. So this is a Fourier series of F even. So F even function has a Fourier series, this one, where A0 is this, AN is this, but on this interval, F even equal to F. So 2 over L, 0 L, Ft dt. And this one, 2 over L. So this is Fe equal to F. So we have this one. So now we have a series, Fourier series contains only the cosine terms, and this one we call it the Fourier cosine series of F. Define that as the Fourier cosine series of F. F initially is given to us on the intervals 0L, and we extend this to the full periods minus L to L. And that's function, the extended function F to F even will be a periodic function. Full period is 2L. The Fourier cosine series of F is then given by this formula. Ft equal to this, where A0 is given by this interval, and An is given by this interval. So this is a Fourier cosine series of F.